Hello and welcome to the SME Focus Show powered by MTDCNC. I'm Mark Weymouth from the Sensor Specialist Plus Automation. I'm your host this week to highlight an aspect of UK manufacturing and in particular SMEs. My guest today is Julian or Jules Morgan, who has been the joint MD of KPM Marine Design Engineering for the past 32 years. Hi Jules, welcome to SMEFocus.
Hi Mark, how are you?
I'm good, thank you, and thank you for coming on today and fighting the challenges we've had with getting this recording done. It's very much appreciated. So, if I kick off, before we talk about KPM, can I ask you about some of your interesting first entries into work? So I know that you started with Philips Design and that led to some exposure to total quality and purchasing. So can you tell me a little bit about your early life and first jobs, please?
Well, before I worked for Philips Design, I worked for a company called Soil and Rock Instruments, based in Upfield in East Sussex, where I did an apprenticeship. I was due to go into the Royal Marines at the age of 16, and 2 days before I was supposed to report for training, I was offered an engineering apprenticeship at Soil Instruments. I failed everything at school. I just wasn't interested. And my first job was actually packing potatoes at the local supermarket. So I was doing that at the age of 13, I think it was. But I got offered this apprenticeship and everything changed. Everything changed. I suddenly realized that maths that I was learning at school actually had a purpose. So when you are learning something for the sake of learning, it doesn't have the same perspective as learning something that you can apply in the real world. So maths and physics and all of those things that they were trying to teach me at school, all of a sudden I had this epiphany, as it were, and realized that all of this maths was taught, same as a micrometer or a hammer or a chisel. And so I was sent to Brighton Technical College, day and night release, and from that point on I didn't look back. Now the thing is that I'm quite sure that there are loads of smaller Jules Morgans out there that are failing at school and have an incredible amount of potential and talent, and we need to get them into situations that they can apply their skill, enthusiasm and talents. We can't all write essays. I can't write an essay. I actually have no need to write an essay, but I'm pretty good at design and selling products around the world and making money and employing people. So I think I know that you are massive supporters of apprenticeships, and we need to start passing our knowledge down to these younger people. So that's where I first started. I got such good grades at college. I managed to get into a degree program, and I applied to study manufacturing engineering at Brunel University. Now, at the time, manufacturing engineering back in the late 70s, early 80s was still a rare course. To give you an idea, one Oxford University turned out more history graduates than the country did manufacturing graduates. And there's only probably about 200 manufacturing graduates coming out a year at that point in time, believe it or not. And this is when we still had manufacturing. But back then, there were a lot of different routes. You could do an ONC, good qualification, HNC, good qualification, or you could go and do a polytechnic degree, and that's where a lot of people went to. I managed to get grades to go to Brunel. And the one thing about Brunel at that point in time was virtually every single one of their students was sponsored to go to university. And I was sponsored by basically Philips. Yeah, it was a part of Philips Research Laboratories based in Red Hill.
Yeah.
And the one thing that I specialised in was test and automation technology and manufacturing in cancer therapy machines, medical machines, and also military. Yeah, there's a lot of technological crossover. So so I was fortunate to be very close to a company and involved and immersed in a company that for 20 years its claim to fame was that they had a patent today for 20 years. So, you know, if you look at things like the CD, that came out of Philips Research Laboratories. You look at the compact cassette for Philips Research Laboratories. My thesis that I did for Philips Research Laboratories was 3D printing. Now, this is back in 1986, yeah, but we weren't just 3D printing plastic. We were 3D printing gold tracks on ceramic motherboards that had very high heat requirements in military equipment. So that was my thesis, and you know, I had access to technology that most people wouldn't. One of the projects that I enjoyed most was, I think I was only about 20 at the time, was trying to look at making linear accelerator tubes for cancer therapy machines more accurate. Yeah. So if you can imagine, you have this long tube that you fire electrons down, and they're made from beryllium copper, which we know is incredibly soft. So trying to machine beryllium copper is difficult at the best of time. And these were big lumps, they were this big. And then you would take these segments and then you would electron beam weld them together to make a big tube. And then what would happen, we'd put it on a test unit, yeah, and it was tuned by a really skilled guy with a hammer. And what he would do was slightly dent the side of the electron beam tube, yeah, with a hammer, and that's how he'd calibrate it. And how he knew where to hit it, even to this day, I have no idea. But to try and get the yield of these tubes greater and more accurate, what I did was I came up with a process of freezing to absolute zero the copper beryllium section before machining, yeah. And because it was basically frozen at absolute zero, it was easier to machine. And then what we could do is we could calculate the expansion, yeah, when the thing started to heat up again. And we also found that if we took the frozen elements, put them together, and then electron beam welded them, we got less heat distortion throughout the electron beam. So that was one of the projects that I was really you know, involved in, and I remember how it happened. I was in the manufacturing office at Manor Royal in Crawley, and they were explaining the problem to me, and I just said, well, why don't you freeze them? Just, you know, this is a 20-year-old kid saying, well, why don't you freeze it? Because all of a sudden it becomes much easier to machine, and it was the light went on, you know. And so I think the lesson there is always listen to ideas. You know, I have it on my shop floor, and the guys come up with ideas, and you're going, I never stop to think about that. Yeah. And by the very nature of our qualifications and the university that we've been to, we think that we know everything. and we genuinely don't. And there's always somebody there that sees things from a different angle. And I think encompassing that into an organization where everybody's allowed to question, and look at things from different angles is very, very valuable. And I practice that with my team. I leave them to play around. Contrary to popular belief, you can't see everything on a CAD system. I spend probably about 8 or 9 hours a day on my CAD, and there's only so much that I can see. And generally, the hold-ups in product development aren't the big lumps. It's all those really small things that are going to take you down. And that's where having my team, do what they do, and having the freedom to do what they do makes the company a success, because we become much more innovative and very, very agile. So we can turn on things very, very quickly. And that's why we have a range of customers. We don't go looking for problems and products to develop. All of our products have come by customers saying, we've got this problem, can you solve it? And we set about trying to solve the problem. Now, I have a general rule that if one person has a problem and they've asked it to be solved, that's interesting. That's a revenue generator. If I get 2 people that have asked, then I start getting more inquisitive. If I get 3 people that have asked to solve the same problem, we've got a market. And that's basically how our market research works. If we get 3 people who will ask us for the same thing with the same problem, we set about trying to create a solution. And so we don't have solutions looking for problems. We don't do that. And a lot of product development nowadays is a solution looking for a problem. We do it the other way around. So people come to us with a problem and then we create a solution. So that's how we work. But a lot of that came out of Philips, and that was taken into places that I worked subsequently, and also KPM when I set it up 32 years ago.
Can you tell us a little bit more before KPM, because you had some interesting experiences and sort of got exposed to total quality management. I know you've got some interesting anecdotes of talking about.
I've got some great stories.
Product design.
I've got some great stories. After I left Philips, I was waiting to do. I did my MBA, and I basically worked on a freelance basis. The idea was I'd finish my degree and I would go rock climbing around Europe. Well, that lasted about 10 days before I got totally bored and ended up working for on a part-time basis for companies like Metalbox, making canning machines and things like that. So I did my MBA at Warwick Business School, and then I was picked up by a high-tech consultancy called particularly Arabian Todd and McGrath. And they were very influential within Silicon Valley. So the main office was in Cupertino. So one of the first projects I was given was Apple computers. So I was asked to go in and assess for total quality management the Apple sites. So that was, they still made computers back then in Cupertino. They manufactured in the Hollyhill, and then we had the distribution center in Appledorn. And quality comes in different packages, and it's not just about X and R charts and measurements, although that's a big part of it. It's also about the customer service, how we design the products, how we design quality into the product, So at Apple, I was walking along the shop floor in the Hollyhill facility in Cork, and I was asked to go in and look at making the board repair centre more efficient. Yeah. Anyway, so did a quick tour with the managing director, a guy called Porrick Allen, and looked at what they were doing. And I noticed a great big stillages of used electrostatic boards, boxes. Yeah. I just turned around to Porrick Allen and I said, why are you throwing these away? Yeah. He said, oh, well, because of branding and we wouldn't want the customer to see a used box. And I just asked a basic question. How many of your customers actually install their own PCB in a computer repair? And he said, well, none of them. It has to go to an official repair centre. I said, so how on earth is it affecting your brand? I said, just put another label on it, send it back out, use the same box. In that one comment, they saved 5 million a year in electrostatic boxes. And obviously now things have changed, so it would be seen as an environmental thing, you know. But then back then it was all about, you know, this Apple brand, you know, and the Apple brand manual was literally this thick. Yeah, what you could do and what you couldn't do. Anyway, so that was the start of the total quality package within Apple. Now, when I was at Philips, one of the other projects that I did was we would manufacture for the military equipment and the medical equipment 32-layer PCBs. These things were very, very, very complex. So once those are populated, you would then put them onto a massive pegboard, yeah, and you would run a sequence through the machine to tell you where the faulty components were or whether you were getting the right signals from, yeah. Now, to try and identify where faults may occur, I wrote a program called Profit, yeah, which basically took all of the track data and the component data, and we knew that if you had a MOSFET or a particular kind of component in any sequence, we knew the individual probability of failure of any single component, yeah. And then we knew that if we combined one component with another component in a specific string, we knew what the probability of there being a failure along that circuit would be. So I wrote this program that would import all of the data and then just run a statistical analysis of where we thought the weak points would be. And so what it did was it allowed you vast productivity improvements in fault finding. Nowadays, you would call this AI, or an algorithm. Yeah, it wasn't. It was basically stats and probability. You know, that's what it is. But it would now be given a very fancy name and, you know, driven by AI or something. But you know, back then we were in the 1980s, we were dealing with AI, yeah, and we called them neural networks, yeah. So there's nothing really new. I also did, whilst I was at Philips, I was sent over to Rhode Island and MIT Robotics Research Department, where I won a National Science Foundation scholarship in intelligent robotics and AI. Yeah, that was back in 1985. I was based in Kingston, Rhode Island. And what I learned there was that robots are, you know, they're great for certain applications, but they are incredibly limited in many applications. And I did a project for Westinghouse on electric motor assembly, automatic, yeah. And we used stereoscopic vision, tactile sensors. We used a whole range of technologies to be able to assemble these things up. My speciality was tactile sensors. So if you can imagine pixels on a screen, these are tactile cells, and you can put them on robot hands, or you can put them on a flat plate, put something on it, you can determine the orientation and the shape. And we were using all of this technology. And I remember we got this assembly cell working to assemble up the electric motors. Now, in an electric motor, you behind the bearing, you have a felt washer, and that holds grease. You wouldn't believe how difficult it is to pick up a felt washer and put it into an automatic assembly. Very, very complex. And we ended up with a really simple way of rolling the felt washer and picking it up with 3 pins on the end of a robot effector, and then plonking it in and then pushing it off. And that's how we did it. So we used really basic technology to achieve something that was a human would do with great ease. Anyway, the president, when we'd got the system working, the vice president of Electric Motors, Westinghouse or something, came to visit, and he said, if you were in my position, what would you do to assemble up these motors? I said, I'd take the factory to Mexico and pay everybody $1 a day. That's what they did. Yeah. So whilst we had the technology, it was nowhere close to being ready. And the fact of the matter is that these companies are in for making profits. That is their objective. It's not to have super duper fancy technology that doesn't pay and create profit. Yeah. And so we have to be very mindful when we're selling the latest technology, whether it's actually going to lead to profitability and also agility, because you need to be able to turn things around on a sixpence. Sometimes you need to change direction in the product, and if you've got full automation, you can't do that. People, you can. So it's very important that you balance that out. So I'll go back to Apple. I went in at the board repair center again, and I said, look, I got this program called Profit. We can predict where you are going to have the faults. And just to double check, what I did was I put a cardboard box next to every pegboard inspection machine, diagnostics machine, and just said, right, the components that are taken out, just put in the box. And what we did every day was we verified the components that were in the box that had been found to be faulty with the program, and it was about 75% accurate. So that's pretty good. Okay. Anyway, so we applied some of these really simple things in Apple, and basically project was finished. I returned back to the office that was in Abingdon, and I think it was 2 or 3 months, and they were monitoring what the result was. And I remember being called up by the senior European partner for a telecom with Oric Allen, and they were about to announce the productivity improvement that they had seen from the work that I'd done in Apple. And basically I was expecting really bad news, and I just sat there thinking, I'm so sad. I am really sad. Anyway, and they announced the productivity improvement was 350% for that whole board repair section. Now that board repair section, I mean, it was 40,000 square feet of just full of technology, so it wasn't insignificant. So what then happened was that the total quality approach was wheeled out Apple worldwide based on that project, and the consultancy got a very, very big project to put in and install total quality into Apple. Um, so I realised that I wasn't, I really wasn't suited to flying all over the world, you know, going to these sites and not having a home life, you know, and I wasn't married at the time, but I just decided it was a little bit too much. So I went up and set up KPM, and with everything I learned, I decided that I was going to run this business very differently. It's going to be very people-centric. It was going to be localization in terms of manufacture. It was going to be innovative. It was going to be agile. And it was very difficult to begin with, and basically, you know, people think if you own your own business that it's like being on Dragon's Den, and you know, I've got a startup and I want this amount of funding, and you know, you hear people talk about first level, second level, third level funding for their startup. Well, yeah, okay, it doesn't really work that way. You know, there's actually a lot of sacrifice. You know, I'd have been much better off working for somebody else. It's no two ways about it. I like to say that KPM is an overnight success that's taken 32 years, because that's probably closer to the truth. But what helped me, because my knowledge was so specific, PRTM kept on giving me contracts after I'd left. So I'd be working on an associate basis. To give a really good example where quality is overlooked. The very first palm top computer was developed by a company called Scion, based down in Greenford. And they had the Scion 3, they had the Scion 5, and it was they'd launched the Scion 5 with a touch screen, and the keyboard came out, and you know, it was an amazing bit of kit at the time. And they had this problem with the hinges breaking, and I was asked to go in and do a complete design review of the plastic moldings and the way the thing was put together. And at the time, I think they had something like 250 million. Now, don't forget, this is 1993, 94. £2.5 million worth of warranty claims for broken units. Now, back then, that was a lot of money. And so I walked down onto the shop floor. So David Potter was talking to the PRTM regional director about, you know, the potential projects and how we were going to do this. And they came back within about an hour, and they said, well, what have you seen? I said, I'll tell you exactly what the problem is. And they said, well, how could you find that in an hour? I said, okay, let me explain what I've just seen. I went down to the goods inwards inspection, because all the plastic mouldings were obviously made by subcontractors, and there was this very thin hole, and it was about 1.2 millimeters diameter, and it had to be held to a very, very high tolerance. Now, injection molding machines, a core pin that thin is going to bend, and it's going to break. So I went and saw the head of quality, and I said to him, how do you measure this hole coming in? And he reached for a paper clip, and he puts this paper clip in the hole, and he said, well, if that's kind of square and the paper clip fits in, it's okay. And I just went, what? He said, well, yeah, that's how we check the hole. I said, right. I said, I wouldn't mind so much if the paperclip was calibrated. Yeah, is it a calibrated paperclip? He said, no. I said, okay, what happens if you lose that paperclip or it gets worn? He said, well, I've got a box of 1,000 here. I'm like, what? What? The story there is that big problems are generally caused by something very, very simple. Yeah. And we had two quality factors here. We had digital drawings that had no tolerances on them or critical features on them, and that wasn't relayed to the subcontractor. So the subcontractor was just doing whatever they thought. The other one was measuring what was coming in and getting a stable process. Yeah. So I then said, okay, what happens when you get these moldings in? Because I guess that this core pin's breaking and you're getting moldings in with no holes. Yeah. And so David Potter said to me, oh, well, we drill them. I went, what do you mean you drill them? He said, yeah, we use a special plastic drill. I said, no, you don't. I said, you use a PCB drill. I've been down and seen the setup on the universal miller. I said, you can't do that because when you drill the plastic, yeah, you create a bit of heat, a harder skin, and this pin that you push in is barbed, yeah, so it's not going to work to its design specification. And at this time, I could see there was a guy called McAlpine, who's the design director, who's just breathing a sigh of relief because he thought this was all going to fall down on his head. But the point is, Mark, is that big problems are generally caused by something very, very simple or complete oversight. Yeah.
Yeah.
So on the total quality, that's what I learned there. Do the basic things and do them very, very well. Yeah. And you don't. We have yields out in the KPM factory that are approaching 100%, and that's because what we've done is we've designed in the quality. We know what components, what parts are important, yeah, what features are important, what aren't, yeah. And so one of the problems that I had, some of my CNC engineers, yeah, they're aerospace guys. Well, we're in marine, yeah. So if I put in an 8mm diameter hole, and this was a learning experience for me, they were drilling it to 8.02, yeah. In the marine industry, because everything gets covered in salt and you get capillary action going down fasteners into, yeah, we tend to loosen the holes. So in the aerospace, you'd be running to 8.02. In marine industry, we would be running to 8.5, yeah, because we need to be able to get that bolt. So we design things very differently for a very different duty cycle and maintenance cycle. So it's just small details like that. One of the things that we do we always overrun a bolt by 10mm. Yeah. So say I'm bolting one piece to another piece, I'll always make sure that there's a 10 to 12mm overrun of the bolt to the other side, even if we're going into a threaded hole, rather than cutting the bolt short. And the reason we do that is because if you do strip the thread in a pump housing, yeah, or it corrodes, you can get a backup nut on. Now, when you're at sea and you start getting a leak through a pump and you realize that you've stripped the thread or something many years down the road, you can back up with a nut. So it's stupid little things like that, and this has all become part of our reputation. So so I think one of the things that I do with any of my team is I spend a vast amount of time explaining why we do things the way that we do, yeah, and how that enhances the total quality. The other thing that we do, for example, quality of product. We do a pump that literally dominates the commercial marine market, yeah, you won't find a wind farm vessel or workboat that doesn't run out pumps, and that's because it's been designed to be incredibly reliable. Yeah, and if it does fail, you can fix it at sea. You can fix it. And over 14 years worth of production, we have only had warranty return rates of 0.03% on a product that goes into a very, very tough environment. And now you look at specifications from naval architects or such like, and what they would do is that they would just basically write KPM Predator, yeah, and that's what gets fitted. So that goes into all the specifications. So it's like Hoover, yeah. And we work on the basis that there was a saying when I was younger: IBM computers aren't generally the best, but you're not going to get sacked for buying them because it's not going to go wrong, yeah. So we tend to say you won't get sacked for buying KPM, and that kind of that now has, over years and years of evidence, has become a byword in the marine industry. So that's the quality of the product. We design it so it doesn't fail. We design it so that if you need a spare, you can get it anywhere in the world. We don't do sealed units. We don't do servitization. Yeah, the product shouldn't go wrong. But if it does go wrong, yeah, we will basically take a new pump, send it direct to the vessel by air freight or courier or wherever it needs to be within 24 hours. We don't ask for an invoice. We don't have any warranty claim paperwork. What we do is we make the process really simple. Yeah, and it's like that on all of our products: our seating, our air systems, our fan systems, our cooling systems. We do the same with absolutely everybody. Now, when you go to sea, you need that peace of mind. Yeah. So if you have a bilge pump that isn't working, yeah, you can't sail. Depending on the vessel, if it's a wind farm vessel, that's £4,000 a day. Yeah. So what we do is we put the quality and we own the problem for the customer. Yeah. So that's quality of service. Yeah. On those pumps that are returned, that we get picked up, it's normally again something really stupid. Like one had munched up paper in the impeller chamber, so we just took that out and the thing worked fine. But what you tend to find is that when we send that replacement pump, the customer tends to buy that pump, and then the one that they sent back, they ask for it to be referred. So we get a double sale. Yeah.
Yeah.
And that's just by looking after the customer. Yeah. And the other thing is that if we have a pump that goes wrong, yeah, and as I say, it's only 0.03% of all pumps that have ever gone wrong. We want to know why. Yeah. So the information that we get from that pump is much, much more valuable to us than the cost of a new pump. And we can then use that for continuous improvement or evaluating whether the pump was used in an operating condition that we haven't foreseen. So there's the quality of the design of the product, the manufacture of the product, and then how you deal with the product afterwards and how you look after your customers. Yeah. So we do take a total quality approach, and we own the problem for our customers. That's what we do. Yeah. So that's how we tend to function.
You've used the term having a green mindset at KPM for 15 years or more, which obviously relates to everything you said before, but could you maybe explain what you mean by the green mindset and that way of thinking about things?
Yeah. When I did my MBA thesis at Warwick Business School, it was in future energy trends and product development. So a large multinational. Yeah. I can't say who they are. but it was becoming very evident that CO2 and general pollution was going to become a bit of a moving force. Yeah. So if you look at my executive summary, the last line of my MBA thesis for the executive summary was CO2 will be used as a taxation vehicle for successive governments. Yeah. And basically what I'm saying is that they're going to use this to basically try and get you to clean up. Yeah. And so from that, I then developed my own program, which was called KPM Earth Gain. And it's basically a doctrine that has 10 protocols. So one of the protocols might be localization. So we know that if you manufacture locally, you don't have all the CO2 miles, you're not wasting effort. Now, as a manufacturing engineer, yeah, in our DNA is the reduction of waste, no matter what that waste might be. So travel distance, you want that product to travel as little as possible and come from the closest source as possible. You want there to be an efficient use of material. Yeah, you want there to be preferably very little damage to the environment. You ideally want the material that you're processing to have very, very low energy consumption. Yeah, because these all add up into the gross profitability of the product. So you can, if you go on to Amazon, you can actually buy the Green Manufacturing book that was published by Beverly McNilson via Birmingham University and BCU, and I wrote a number of papers on how the Earth Game works. But basically, what these doctrines do, as you go through them, it suddenly tells you how good you are being. So I was really early into this because I could see it coming. I remember I was at a conference down in Brighton, and it was at the Brighton Centre, and there was this 1980s banker, yeah, with the red braces and complete Gordon Gekko. He had a pop-up booth and he was selling green carbon credits, yeah. And I remember saying to him, I said, so how does that work? How does that get the CO2 out of the atmosphere? How does it clean everything up? And at the time, I didn't recognise the name of the bank. It was completely unknown to me, you know. Anyway, so the guy basically turned around to me and he said, well, we don't really care. It's another thing to trade. And I went, right, okay. How's it benefiting the environment? What's the mechanism? Yeah. Yeah, we don't care. As it happens, it transpires nowadays, you would most certainly recognise the bank's name, and it was Goldman Sachs. Yeah. But I kept on getting all of these kind of signals from various parts of the market. Now, at the time, we were working with, when I wrote that the CO2 would be used as a taxation vehicle, I wrote that in 1988. Yeah. The hockey stick that Al Gore uses hadn't even been invented. Yeah. But we knew that we had a problem. We knew that we had a problem. So I started developing my own doctrine that I applied to KPM Marine. So I know when I design on every single component, from mining all the way through to end of life and recycling, I can tell you what the CO2 output is. I can tell you what the water eutrophication is. I can tell you what the air acidification is, and how much energy it's used from mining all the way through to recycling. Yeah.
Wow.
So I use the Dassault SolidWorks system, and I use their Sustainability Express. So as I'm designing a component, I can tell whether I'm designing efficiently. So if you look at one of our suspension seats that are probably the most popular in the market, we managed to reduce the CO2 component, yeah, from 200 kilograms of CO2 down to 58, yeah. And the way we did that was we specified primarily aluminium, but we specified recycled aluminium, yeah. Now, aluminium is very expensive to make in energy terms, but recycled aluminium only takes 5% of the energy to convert the aluminium into new aluminium, yeah. And it's virtually infinitely recyclable. So we manufacture all of our products out of aluminium, and of all the aluminium that's ever been created by man since its inception, about 80 to 85% is still in circulation. So in terms of circularity, yeah, and lifetime, aluminium is incredibly versatile. So the aluminium that we use is it comes from Norway, and it has a CO2 footprint of 4 kilograms of CO2 per kilogram of material. Now, if that was original material, it would be a lot higher. It would be around 16 kilograms of CO2 per kilogram of aluminium. Yeah. So what we did is we went through and made sure that we had high recyclability of all of our materials. So we don't have plastics that have volatile organic chemicals. We stay away from anything that can't be recycled. Yeah. I often quote to people when I'm lecturing on sustainability. If you left a box full of aluminium cans outside your house and a box full of plastic yogurt cartons, which one gets nicked fastest? It's the aluminium. And the reason is because plastic has very high utility value. It doesn't have high aftermarket value. Yeah.
Yeah.
So we manufacture all of our products with materials that have what we call end of life value. Yeah. Now, when we did all of the interior systems, seating, pumping, and air systems for the Bahana project for the Royal Navy, which was 40 boats, we pointed out to the MOD that at the end of life, that virtually all of the product that we had supplied, about 96% of it by weight, had an end of life value. And they said, what do you mean? I said, well, it's exactly like an airframe. Yeah, on an airplane, it has high end of life value. So people will want that aluminium. If they can get hold of the jet engines, they want the titanium in the blades. So and it was basically something they never stopped to think about. So instead of using plastics or foams or a number of materials like carbon fiber and composites, composites are awful, but end of life value. And once they break catastrophically, they are generally difficult to fix. With aluminium, you can keep on repairing it. So we created this thing called Earthgain, and for about 8 years now, I've been supplying what we call EPDs, which is environmental product declaration documents of every single one of our products, detailing the CO2 from beginning to end, water purification, air acidification, and the energy consumption for manufacturing that product. And when I send them to customers with quotes or specifications, say, you need this, you just don't know that you need it. Yeah. So we've been sending those out for about 8 years now, and slowly people have suddenly realised that they need to start including it in their environmental declarations. So yeah, that's the story behind why we got into it fairly early. Yeah, and you know, we can't carry on doing what we're doing, you know, and you know, I don't know about you, but sealed units and things that I have to throw away and can't repair drives me round the twist, you know. And so I designed all of that out of KPM products, and that's been appreciated. And you know something, we get a premium price for it, that it is repairable. Yeah.
Right.
So it makes good business. Green makes good business if you do it right, but you mustn't lie. You mustn't pretend that you're doing something or rebadging, you know, when in fact it's not true. There has to be some kind of substantial depth in what you're doing. And you know, a lot of green is they're just sound bites. You know, it's like AI. You know, I saw you can buy an AI dog bowl. You know, excuse me, but yeah. So we were very early into green.
Okay. I guess when you talk about green, you've demonstrated how you've designed with that in mind. And I think I described you as a designer who's got a passion for physical products and practical solutions. So you're working far beyond just the CAD screen and thinking of the greater issues of manufacture practicality. I know you're involved with the ventilator challenge, which I think is a good example of looking for a practical solution. So could you tell us a little bit about that?
Yeah, when I was at Philips in the medical, one of the projects that I was involved in, you know, wasn't leading it, but we were trying to get analog ventilators over to digital ventilators. Yeah. So I had an insight into how incredibly difficult that is. You know, you've got so many levels of calibration. These things are complex. They're hard to make. Yeah. Up until that point, we had used mechanical analog ventilators that were basically valves and dials. Yeah. And you know, on-demand valves. You know, very similar to you'd find in a diver's mouthpiece. And so I put myself up and basically said, right, okay, I've got a bit of experience on this. And I managed to track down a ventilator that was very, very popular maybe 20, 30 years ago. It's called the Bird 10. Yeah. So I set about getting all of the details, contacted to get a license for the Bird 10, even though it wasn't manufactured anymore, and did a full cost analysis of how to make this thing. Anyway, posted it on LinkedIn and Twitter, and said, right, this is my solution. Yeah, and I had 2,000, I think on LinkedIn, 2,000 medical practitioners saying, yeah, this is exactly the right way to go. Yeah. So I calculated that we could make these things and all the bits and pieces in pretty much every workshop in the Midlands, if not the country, as you could pretty much over the world. And so I submitted this to the Home Office. Yeah. And basically had a number of conversations with them about the merits of using this, and that most practitioners knew exactly how to use them, and even to this day people are still trained on them. Yeah. So one practitioner said, well, we have a room full of these in King's Hospital, I can give you the room number. In And when it came to the settings, there's three dials that you can set, yeah. And I had practitioners saying to me, yeah, you set it at 20, 20, 20. That would be the perfect setting, yeah. So we had massive buy-in for this. Anyway, so I sent everything down to the Home Office on the ventilation challenge. And I get a phone call from the Cabinet Office. It was a Thursday night at 10 o'clock, I remember. I was in the utility room, and my wife came in with the phone and said, oh, it's the Cabinet Office. And basically said to me, we reviewed what you've done. We're going to use your solution as the break glass in case of emergency solution. I was very happy with that, because don't forget, there was this guy in this company in Birmingham that was up against the might of McLaren and JCB and Dyson, that were all getting involved in this, and I was kind of the reserve solution if it didn't kind of go right. So yeah, I was happy with that. Yeah, I wasn't going to make any money out of it. I just wanted everybody to get together and start making these bits and assembling them up and doing something for the country. Anyway, so I let it go and just carried on doing my regular day job, as it were. And then I found out that the Americans had launched a program under the War Production Act of making 50,000 ventilators in 100 days. Yeah. Now, when you got the likes of Ford and General Motors behind this, one thing the Americans are brilliant at is scaling up, production scaling. I found out that the unit that they were proposing was exactly the one that I had proposed. They put it in a slightly different box, painted it blue, and called it the Megavent. Yeah, and the irony is that they made 50,000 in 100 days because of its simplicity. Right. Now, I was on the BBC talking about this, saying, no, you've got to go back to simple manufacture if you want to respond to this threat. Yeah, and it's a good example where governments are not good at picking solutions and winners, when in fact the Americans have been a lot more pragmatic about it and said, okay, what's the bare minimum we need? So if you have a situation that you have 50,000 of these ventilators available, or you could have the fully electrical, all singing, all dancing ventilator, but you could only have a few of them. Well, what you need is the critical situation is that you've at least got something. So even if that ventilator was only 80% as good as the electronic ventilator, it's still doing something, and it's better than not having nothing. Yeah, and when we're making decisions, we tend to work on the basis that it's got to be the perfect solution to the specification. We lose sight of what we're trying to achieve. Yeah, so 50,000 ventilators that are 80% efficient is better than 3,000 that are 100% efficient. Yeah, and a lot of this comes down to corporate. A lot of it comes down to academic expediency. Yeah, and so we find ourselves sometimes making decisions that are not suited to the circumstances we're in. Yeah, and that's what happened with the ventilators. We were just aiming too high rather than trying to create a solution that would just be enough to give people a chance. Yeah. And so, I don't know, have you ever seen one of the ventilators that came out of the ventilator challenge? I haven't.
Not the UK ones, no.
No, but the American ones, so I understand. I've not seen one. I most certainly know they went to Africa because we were asked by a large African charity to help. And I do believe that some of these ended up in the UK. So, there's a lesson there. You can't be too precious if you're trying to solve a problem.
Yeah. So a bit of a change of tack and direction, if I could. I know you're an ambassador with the Coventry and Warwickshire Children's Charity, so that raises money for NSPCC and founded Bull House in Coventry, and it cares for vulnerable youngsters and their families. Can you tell me about your involvement and really as much as you wish to tell us about the charity and why you support it?
Well, we do. KPM actually supports a lot of charities and individuals, but we don't kind of do it on a formal basis. And we never use it for promotional. We prefer people not to know that we're doing it because it wouldn't be right, to use people's circumstances for your own promotion. So, yeah. But the Coventry and Warwickshire Children's Charity, I came from a very deprived area, and my family, we came from poor, so we know what it feels like, and we understand deprivation. Yeah, and if you look at the Coventry and Warwickshire Children's Charity, there are 700 children on the at-risk register. Now that is physically abused and sexually abused. That's 700 just in Coventry. Yeah, and the social services at Coventry Council, they just can't keep up. Yeah. Now the house, the safe house, or the area, the unit that you're talking about, that was actually sold by the NSPCC. So the Coventry and Warwickshire is an independent charity now. Yeah. So the one thing that was set up in Coventry to support children of Coventry was basically sold by the NSPCC. So the Coventry and Warwickshire Children's Charity was set up to be able to try and rectify the situation and raise money to give these children support. And these children come from so many varied backgrounds. Yeah, and I just think that it's our duty to ensure that we are putting back into our communities. Yeah. Because for the last 30, 40 years, we've been taking away jobs, sending factories abroad. Yeah, and this creates massive pockets of deprivation. And I believe that companies like mine and all companies should be putting back. Yeah, they should be putting back. And no, it doesn't matter how much, at least try and put something back. Yeah. And that's the one thing that children's charity at Coventry, Warwickshire is looking to do. But it is a massive problem. We need to do something. We need to do something about it. So the charity has some amazing people, that go above and beyond in trying to raise money and ensure that these children have a safe future, or a future at all in some instances. Yeah. So that's my involvement. So I was asked to be an ambassador for the charity. which is
great. Well, thank you for telling us about them. So we wrap up the episode. Can I ask how people would go about finding you if you're on LinkedIn, for example, and how they contact you?
The easiest way is to go onto LinkedIn. I don't do any other social media. I don't do Twitter or the others, TikTok or anything like that. Instagram, I think, is popular with my girls. Yeah, basically email us or LinkedIn. LinkedIn is pretty much the only thing that I use. So, if you want advice on green issues or how to set up your business, or you want, a friendly word of advice, or you want to know more about the Coventry and Warwickshire Children's Charity, then contact me via there. I also do, I represent the Warwickshire and West Midlands tenancies. Yeah, so I help promote the King's Award for Enterprise. Yeah, and it's fascinating the kind of companies that you come across, and you have small companies that are innovating. They don't know what the scale of their innovation is. They genuinely don't see it because they're too busy doing what they do. So I would suggest or recommend to any listeners of this, go and check out the King's Award for Enterprise. Yeah, there's 4 categories. There's export, there's innovation, there's social mobility, and then there's sustainability. And just the process, if you're growing a small business, just going through the process of filling out the paperwork for your own purposes is of very high value. So yeah, that's the other thing that you'll see on my LinkedIn page. I promote that quite heavily.
Brilliant. Okay. Well, thank you very much for that. I will wrap up with the general words at the end of every show. So if you'd like to get in touch with the show with a comment, a suggestion, or if you'd like to appear particularly in a future episode, please email us at inquiries@mtdcnc.com or contact myself, Stuart Whitehead, or Joe Reynolds. Thank you for watching. Enjoy the rest of your weekend. From me, Mark Weymouth at Plus Automation. Cheers. Have fun.